Okay, let's start the session. Okay, so yesterday we started with the Delta features. So I shared this IPython notebook. I can go through that. And today we'll understand the merge and the clone. Okay. So Delta is having many features, but a few features are not still available in Fabric. One is uh, liquid clustering at PySpark level, which we discussed that. And another one is cloning. Like cloning, we have two types of cloning, shallow clone and the deep clone. Cloning part also, some limitations are there. So first we'll understand the merge. So how we will do merge in a SQL, how we will do merge in a PySpark. Okay. So when we will use merge first, and then how we will use that. So before that, let's revise yesterday one, Delta features, then we'll go on that. So what is Delta? Delta is an open source API to enable ACID properties on top of file system. File system means distributed file system, which is an open source project started by the Linux Foundation team. Okay, so if you go to delta.io, the Linux Foundation team, they started this open source project, and then Databricks team and the Linux Foundation team, they coordinated and they started initially with the Databricks. Now it is available with many ecosystems. Many ecosystem means initially it was available with the Spark. Spark means Java. Then now it's available in many Java systems where we can use in Synapse, where we can use in other cloud infrastructure, like if you are going for EMR, okay, if you are going for Hive or any other cloud environments, wherever Java-based ecosystem is there, still it will support a Python-based ecosystem like Pandas and Rust-based ecosystems like Polars, Arrow. So mainly you can find this Rust-based and Python-based for data science and machine learning projects. So there also we can see this Delta Lake usage. But Delta is just a API. It's just a API. It will enable you to process data or store data in a particular format, and to enable on top of that all the database features, all the database features. So we are using a Spark here. We are using a Spark. So that may be in a Fabric or maybe in Databricks or Synapse or EMR. These are Spark-based ecosystems, Spark-based ecosystem. Spark is a server, processing server. And then backend, it will be a data lake. And even Delta can integrate with other competitors like Iceberg and Huri. Okay, so it supports other formats also where we can go and use format type called uniform. It's a new feature recently introduced, but currently it's not available in Fabric. But still, it's like a new feature where even you can use the same Delta and create as a uniform format that it can read through Iceberg or it can read through Hudi also. Iceberg is just alternative for Delta. Mainly you can find in BigQuery and Snowflake. And Hudi is an alternative for Delta. Mainly you can find in uh, like Impala and other ecosystems. Even some customized projects in AWS. You can find this Hudi also. But these are alternative to Delta Lake. Iceberg and Hudi is alternative to Delta Lake. And there also many companies are implemented using Iceberg, implemented using Hudi, and mainly customized project, like it's open source projects on AWS infrastructure. But anyway, we are talking about Azure. Then Azure Synapse Analytics or Fabric or Databricks, mainly you can find Delta. Okay, mainly you can find Delta. The backend may be any data lake. Backend may be any data lake. These are the features. ACID transactions. So consistency, integrated, durability, okay, atomicity. So when we look at any database, those database features are available part of the Delta. Scalable metadata management, it is going to keep all the metadata in a JSON files. Time travel, it is going to keep the edit logs. That edit logs will have a complete snapshot-based versioning, snapshot-based versioning where you can go and get the previous version data, you can go and restore previous version data. Time travel also is possible that we saw yesterday, and it's an open source. Open source means many people are contributing, which you can expect more contribution and more features in the future. And then it supports schema enforcement and schema evolution, which we discussed yesterday. Then edit history, it is going to keep all the Delta logs, supports the DML operations. The DML operations which you can use SQL or even programming language like Scala or Python. Okay, so DML operations which we can do through a SQL or through Python. Python and nothing but our PySpark or Scala also. It depends on the programming language. So for that, what we'll do, we'll understand the merge, how we will use a merge, because merge is widely used for incremental load. Merge is widely used for incremental load. Like if you want to identify the data in target table, then if not available, insert the data. If available, update the data. So we can go and use merge. For that, what I'll do, I'll create a table. You can treat as a table which is having some data, employee ID, name, and the location. And you can treat this as target table. Means target table already having some data. Then we'll create some file. The file you can treat as incremental data file, which you are getting some data as existing data, some data as new data. So this is your data file, which is incoming data from source. Table already available, data already available. But you are getting a data file. That data file contains maybe existing data, consider its ID 1 and 2, which is some modified data. And then new records, which is 10 and 11, which is not available in the table. So the file is having 1 and 2, which is already available in the table, and the 10 and 11, which is new records. So it should compare with the target table. It should identify if a record is available, then update the data. Then not available, then it should insert the data. Not available, should insert the data. So let's create a view. So you can create a data frame, you can create a view, then you can do the merge in SQL. So merge in SQL. So this is standard syntax in every database. So Spark SQL also will have the same syntax, like delete it from table, insert into table, update into table, like merge into table. Syntaxes will be same, SQL syntaxes will be same. So merge into target table, the target table already available and it is having some data. Using this view is from this table, that file. We created a data frame. So data frame, if you want to use in a SQL, we can create a temporary view. So we already discussed one of the transformation. So what is a temporary view and how to create a temporary view and when we will use this. So this temporary view we can use in SQL. Okay. So now this is a source and you have a target table. Merge into target table, you can use alias name as this. Using source table or view, that is the view, the alias name, and condition. Merge always works on condition basis. So that condition basis it will work. So if the condition is satisfied, means when matched, then update the data. Data means star means all columns or set of columns also you can specify. Only few databases it will support a star. Some databases it won't support star. You need to specify manually the column list of columns which you need to update. Normally traditional databases won't allow to update a primary key column. Okay. The primary key column is on condition. You are verifying the condition. If the record is available, that record only you are going to verify, right? That column it won't allow to specify in the update class in traditional databases. Okay. But here you can use the star. That's why it is allowing star here. Because there was no constraints concepts here. Because traditional databases will have a primary key concept. So you can't update a primary key in the merge because you are verifying based on that primary key only. So that's why primary key columns on condition columns, it won't allow in verification. Okay. Verification, whatever you do this verification, those columns it won't allow in the update. But here it will allow. That's why we see here star. The when not matched means the record is not available in the target. When not matched, then insert. So you can use a star, I can use the values also. Okay, we can use the values also. Insert into particular values on the specific columns also. Star means all the columns. Now, this two records should be updated. This two records should be inserted. So what we'll do, I'll take this. Remember this merge, it will support only a delta table. Okay. If it is non-delta table, even delete, update, merge, you can't use non-delta tables. Okay. It should be a delta table. Now this is having data, target table is having data. So the 1 and 2 should be updated. The latest data is latest data. And the 10 and 11 should be inserted. Let's run this merge. Merge is, we will run as incremental load. Incremental load means it will verify in a target table. Data is available. How it will verify based on this condition. This condition is important. So out of 4 records, 2 are updated, 2 are inserted, which you can see here. Okay. Same thing you can achieve through Spark SQL also. You can go and write in a Spark SQL. Spark.SQL. You can use a triple quotes. So then you will get that output. 4 records is updated. Why it is updated? Because we already inserted here. Now the target table is having all the records. 4 records are updated. So even if you use Spark.SQL, if you execute a merge, you can store as output. So it will create a data frame with that, with 4 columns. Number of rows are affected. In that, how many are updated, how many are deleted, how many are inserted. Okay, that's the advantage of merge. Merge will give you the output also. How many records are updated, how many are inserted, how many are deleted. Even merge supports insert, update, delete 3 operations. So that output also which we can get. If you are using a SQL, you will get directly output here. But if you use in Spark.SQL, you can store into some data frame. That data frame will give you the output. Data frame give you the output. So that output. So this is merge in SQL. Same merge even you can use in PySpark. Like here we use a star, right? Star means all columns. So Python means purely functions based. So there is the API is available, which we need to import that API. I'll show you that. When matched, the separate class is available. When matched, delete is separate is available. When not matched is available. Okay. Like here in SQL, we have a spaces like when space matched space then. Similarly, when space not space matched. And SQL is not a case sensitive. SQL is individually reserved keywords. These are reserved keywords. It's not a case sensitive. You can write in any case, but better to write in uppercase for all the reserved keywords. These are reserved keywords. Merge into, using, on, when matched, update, set, not matched, insert. These are reserved keywords. Okay. But in Python, when it comes to Python, it's always a classes and functions. Okay. We have a separate class called when matched. It's a case sensitive because Python is a case sensitive. Similarly, we have another function called when matched all. Then update all and insert all. We have that functions also available. When matched, delete, not matched, then you can do the insert. So for that, the Delta table API is available here, delta.tables. So we can import this for name. We can create a Delta table object. Like we'll create a data frame, right? Similarly, in PySpark, we can create a Delta table object. Okay. So first we need to create a Delta table object. In SQL, your target table is this one. But PySpark, it may be a data frame or it may be a Delta table object. So here the Delta table, this is a target table. First we need to read by path. If you are using a Delta table.far path, you can specify the path where it is available. Or you can use Delta table.far name. Far name means your Spark session or table name. Now this is the Delta table object. On top of that, you will have a transformation called merge. You'll have a transformation called merge. Now, if we go and use a help, it's a Delta table object, okay? Now you will have a multiple options on Delta. These are Delta features, okay? You can use a far path, you see here, for name, create or replace, create if not exist, create a session, convert to Delta, vacuum. These are Delta features which you can use in PySpark. These are functions are available. Non-optimized. Merge is one of the function. So it will have obviously merge will have 3 arguments, another data frame, and the condition basis, which it will verify. Then you can use on top of that the classes. When matched, update, not matched, insert. Update means a set of columns. Key value pair, JSON. Insert means even that also key value pair. Finally, we need to use execute. To trigger that, we need to execute function. There's the execute function on top of that we need to use. Even we can use it with the conditions also. Like when you are like multiple conditions also, which we can use, or one even when matched update. So here this is your merge. Within that you have another data frame and the condition. This is your source data frame and the condition. So we have a functions. Now we'll create a same data frame we'll use. I'll recreate this table because we did in a SQL. Same thing we'll try in PySpark as well. So now this table is having up to 9 records. You see 10 and 11 is not available, and 1 and 2 also some old data. We'll update that. Okay, we'll update that. So now first we used merge in SQL. Now we will use merge in PySpark. So this is target object. Then we'll use that. This is a source view. This 2 records should be inserted. This 2 records should be updated. Okay. So your target object, you can create alias name. In a SQL, we'll use as. In PySpark, we'll use alias function. Data frame also you can create alias name. So merge, first argument is another data frame. Then the condition, alias name we are specifying here. This is target table, it is having ID. This is source data frame, it is having ID. We can use it directly, like star we use in SQL. Here also we can use when matched, update all. When not matched, insert all. Like we used a star, similarly here we can use all. Then if you do this, If the data is available, it will update. If data is not available, it will insert. Now we can go and verify. Can go and verify this table. Now you see here, these two records are inserted. These two records, existing records only just updated. These two records are not inserted. If it is inserted, you can find the duplicates. So it's not inserted. So it is updated. Okay. And these two records are inserted. That's why we see now all the records. So we are able to do merge with the SQL, merge with the PySpark. So merge is an API from Delta. The Delta table it supports. Other formats it won't support. Other formats it won't support. So we have to use with Delta table only. Now, so this is about a merge. So merge is standard SQL operations. If you are comfortable in SQL, you can do in SQL. If you are comfortable in PySpark, so there's no difference in the performance. Everything will be same. There's no difference in the performance because even it supports in other language like Scala also. Next one is cloning. So cloning is just creating a backup table. That's all. Cloning is creating a backup table. That's the cloning concept. But Delta support two types of cloning, shallow clone and deep clone. Shallow clone is zero copy cloning, which is similar to Snowflake. Similar to Snowflake also we have a zero copy cloning, or you can say no copy data. Okay. Another one is a deep clone. Another clone is deep clone. So let's create a table first. I'll create this table. Then it is having some data. Then we'll understand the cloning. Okay, how to create a clone table. Clone table. Normally we will use, if you want to create a backup table, we'll use a create as a table select query. Create as a table select query. Similarly, clone table also create or replace table, then a shallow clone on the parent table. Okay. From this table to it will create another table. But we are using a shallow clone. The shallow clone is nothing but zero copy cloning. Zero copy cloning means whenever we create this table, table will have a data and the table will have a data files. Let me verify that. So here you can find the data files. Let's verify is inside tables, lowercase. Okay. Yeah. Now you can see the data files are available here. Underscore delta log and the Parquet files also available. Okay. So now, if I create a shallow clone, so when you query this table, you can find the data. You can see the data is available in this table. But if you go and verify in the backend, you can't find the data files. No data files. Only delta log folder is created. There you can find the JSON file. The JSON file again, if you go and verify the JSON file, the JSON file contains the table locations. The data files, again, it is going to refer a main table only. If you look at this every data file, this is data file, where it is located, department table only. So what is shallow cloning? Zero copy. Zero copy means you will have a table and the table will have a logs, but the logs will refer main table only. Then it is similar to view, but it is not a view. Then what is the difference? If I have a view, if I insert any new record into this table, okay, if I insert another record, that record will be available in the view, right? But here, insert another 50. Just I inserted another record. So that record will be available in main table. If you go and query this main table, you can find this. Sorry. So this record won't be available in clone table. See, even if you delete that, it won't impact. Even if you update that, it won't affect even. Because this is snapshot based. Snapshot means till that whenever you create this shallow clone, till that time it will create a table and it will have the data. Because it will refer the old data files, whatever the data files are there. Until these data files are available, it will be available. Okay. Shallow clone, when to use this clone? Shallow clone is like snapshot based view. Snapshot based view. We can access data in that particular snapshot. Until those snapshots are available. Okay. Okay. When we can see issues like data files are not available or snapshots are not available. If we do any deletes on main table, those snapshots will be deleted after 30 days. Okay. And or if we do any vacuum or optimize, so those files will be deleted. Until then, we can access this data. If you run optimize, then those files will be deleted. Or if you do vacuum, let's go and run the vacuum. Like if I delete that table, okay, if I delete this entire table. So this is having data, right? What we'll do, we'll delete the data. Even if you delete, the data will be available in shallow table. Why it is available? Even if you delete those, if we do any deletes on main table, those snapshots will be available after delete like 30 days. Okay. available for 30 days. Okay. Or if you do any vacuum or optimize, then those files will be deleted. But if you don't see data in this table, but clone, zero copy clone, still we can see the data. You see, main table does not have a data, but this shallow clone table, still we can see the data. But these data will be available only for 30 days because we already deleted. Or if you do the vacuum. So what is a vacuum? Vacuum means deleting deleted data. Like if you go and use a versioning, like a version as of 0, then you will get that data. Version as of 0 table creation. Version 1 is like insert 1. Okay, version 2 is insert 1 and 2. Okay, version 4 will have a 4 records. Okay, version 5 will have a 5th record. Okay, this is about. But still we can see the data through time travel. But those files will be available for 30 days. But if you do vacuum, so how to run the vacuum? Vacuum. Retain. Number of hours. Can you retain 0 hours? Vacuum, we can't retain for 0 hours. It will raise exception like this. Raise exception. Are you sure you want to vacuum that files for that entire deleted data? Now vacuum can delete only deleted files only more than 7 days. 7 days, or you can say 168 hours. Older snapshots. If you want to delete less than 7 days or 168 hours snapshots, then we need to disable that validation. So it is trying to validate this. Okay. Are you sure you want to delete less than 168 hours? If you want to delete less than 168 hours, you need to set this parameter to false. This is a retention duration check. Disable retention duration check. This will check that retention. But the default retention is 7 days. Even if you run the vacuum, it won't delete less than 7 days data. Still, you want to delete less than 7 days data. So you need to disable that. So how to set any parameter? So Spark session variable conf.set. Set is a, you can go and set this. First, you can get the parameter value. The parameter value is true. Then set is the 2 arguments. First parameter and the second one is false. Sorry, spelling mistake. Now I said that.
Databricks UTIL, right?
So the parameter will be same because it is developed by Databricks, right? So the parameter will be same. Now we set as false. This parameter, they not change this, still the parameter is same, okay? Because it's developed by Databricks initially. The parameter still you can find this Databricks. This is delta related parameter, okay? Now we can go and now we are trying to do vacuum. Now it is deleted. Now if you go and query shallow table, you will get error. What is error? File not found. Because those files are already removed. Okay. When we see errors in the shallow clone, if the parent table data is deleted, even if it is deleted, still it will be available for 30 days. Then when you'll get that error. If you do vacuum means deleted data snapshots, we are going to delete it. Deleted edited data snapshots. So whatever we do delete, that still it will be available in the backend, but it will be deleted after 30 days automatically. But before 30 days, if you want to delete, we can use a vacuum. Vacuum is another feature. Purging. Vacuum is another feature. Purging. So this is about cloning feature. So only a shallow clone is available. Deep clone is not available. If you're looking for a deep clone, you can go and use another option called CTAS. Okay. Let's create the table again. What is CTAS? Create table as select query. How to create a backup table? So you can go and use create table name as select from. This is called creating a backup table. It will have a data and it will have a metadata and everything. So data is available. If you go and verify in the backend, you can find the backend files also. Okay. This is one transaction, so it's created a one file. If you insert, let's understand another concept called vacuum. Sorry, optimize. Let's do this inserts. So whenever you do individually, every insert is one transaction. Okay, always remember this is one transaction. So one file it will create. Every insert is one transaction. Okay, every insert is one transaction. Just I'm trying to do just multiple inserts, then multiple files will be created. Now we'll go and verify this table, how many files it is available. Can you use the describe detail? Describe detail. But 30 files are available. Just a small data set, but 30 files are available. Why 30 files are available? Because we did multiple times insert. Every insert is one file it will create. But it is small data set. Number of rows are very less only. So if you go and verify the number of rows, just 30 rows. 30 rows, 30 files it is created. So that's called small files, we'll call it as. So if you go and run optimize table, what will happen? It will remove all the small files and it will recreate. It will recreate. You see here. This is the number of files. The location. Let's go and describe detail. Now only one file. Same number of records. 30 records, but one file it is created. Why only one file? Optimize is going to remove that all the files. Optimize is going to remove. What will happen? It will remove all small files and it will recreate new file with average size GB. If you have a more than 1 GB, then it will create a more than one file. If you have a less than 1 GB, it will create one file only. That's why one file we see here. Why one file? Because our data is less than 1 GB. That's why one file. If you have more than 1 GB, then it will create, if you have a 10 GB data, it will create 10 files. If you have 100 GB data, it will create 100 files. But less than 1 GB, like 500 MB, 200 MB, 1 MB, 10 MB, 20 MB, doesn't matter. Less than 1 GB means it will create only one file. Okay. But whenever you do optimize, it will remove all small files, then it will recreate new file. So when it comes to physical, it won't remove. Okay. After optimize, old files will be logical delete. Still, it will be available in that table location. 30 days. Okay. Available in the table location as snapshots. Now, if you go and verify that location, still you can find that. Tables. See, still those files are available. It's not deleted. So it will be deleted after 30 days. It will be deleted 30 days. If you don't want to keep the 30 days, then you have to do the vacuum. Vacuum, table name, retain, 0 hours. I don't want to keep anything. Just remove everything. The deleted files. Optimize is going to remove files, small files. Now, if you go and verify here, you can find only one data file. Okay. Now it has deleted everything. So today, two additional concepts, total 4 concepts. One is merge, one is cloning, one is a vacuum, one is optimize. Optimize is required to remove small files. If you have a more number of small files, then go and run. It will create average file size 1 GB. Vacuum we will use to remove deleted data files. Deleted data files will be there for 30 days, or you can say older snapshots will call it as. If you don't want to keep for 30 days, if you want to remove those, then use the vacuum. Vacuum default, it will keep 7 days and it will remove greater than 7 days. If you don't want to keep the 7 days also, then go and use a retain at 0 hours. Go and use a retain 0 hours. The retain 0 hours is going to remove everything. So this is about today's like delta feature. These are delta features. Yesterday also we covered delta features. Today also we covered delta features. Let's revise it one more time. Whatever we covered yesterday and today. First, delta supports ACID transactions. Okay. Delta is an open source. Delta uses Parquet file as data storage and JSON file as log. Metadata, statistics, storage. Delta supports DML operations like insert, update, delete, merge. Okay. Delta supports schema enforcement. And schema evaluation. Schema enforcement means any mismatches in the schema, it will enforce that and raise error. Schema evaluation means merge schema, allowing us new columns for allowing new columns. Schema enforcement means raising error if any schema mismatch. It's called schema enforcement, schema evaluation. Then Delta supports time travel, so which we can go and get previous snapshots using a version number or timestamp. Delta supports restore. We can restore previous version data. Okay. Delta supports cloning. So currently here it supports only a shallow clone. Or you can say zero copy. So snapshot based views, or you can say cloning will call it as, but it is mainly temporary use cases will use a shallow clone. Delta supports optimize for removing small files and creating new files with average size GB. So Delta supports vacuum for removing deleted snapshots files. Default, it will remove older than 7-day snapshot. Okay. With the retain, you can remove less than 7 days. With the retain option. Okay. So these are our Delta features. So Delta supports partitioning, clustering. So which we already discussed this partitioning and clustering in the previous session. These are our Delta Lake features. These are our Delta Lake features. So today cloning mainly when we will use. So if analytics team, they want a particular till today they want some data. Okay, maybe some testing or maybe any other analytics. Temporary use cases will use a shallow clone, not for permanent. Because permanent use cases, what will happen if you optimize the table or if you do delete, if you do update, that older snapshots will be deleted after 30 days. So shallow clone cannot keep the data for longer time. Shallow clone only for temporary use cases, but without copying another data. Instead of keeping two data files, just for temporary use cases, we can use a zero copy cloning. That's called shallow clone. Shallow cloning is nothing but zero copy cloning. If you want to create a really backup table, then go and use deep clone, but deep clone it is not supported here. We can use a create table as select query. CTAS, we'll call it as CTAS. Temporary use cases. For a permanent backup, tables, you can use deep clone or CTAS. So create table as select query. Okay. So CTAS, we'll call it as CTAS, create table as select query. So anyway, here a deep clone is not supporting. You can go and use a CTAS, create table as select query. These are all the delta features. Major features are like time travel, partitioning, clustering, and optimize. Okay. Major features are partitioning, clustering. Even whenever we do optimize, even we can apply a G order by. So G order by is another option where it is like a clustering. It is like a clustering, but when it is creating a new files, can optimize means reducing the number of files. While recreating a new file, it will store nearby data in one place. It will store nearby data in one place. So consider department number is frequently if you are using, then go and run optimize the G order by and department number. Up to 4 columns we can use. It is not a partitioning. It is while recreating a new file, nearby data it will store in one file. But this will help you only if you have more data. G order by will help you if you have more data because 1 GB file it is going to create. So G order by can apply for bigger tables, not for smaller tables. Okay. G order by can apply for bigger tables, not for smaller tables. Okay. So this is about delta features. So delta lake backend anyway, it is going to store data in a Parquet format. Data is always will be in a Parquet format. Parquet is one of the best suitable format for Spark. Then logs, statistics is going to store in a JSON file. So every table will have underscore delta folder, which we went through that. If we go and verify every delta table, so remember that architecture, delta architecture means it is going to store. Let's set this loading. Oh, looks like. Sorry, guys. Looks like some network issues. Can you hear me?
Yes, Ravi.
Okay. Maybe some slowness in the network. Okay. So that's about delta feature. So I think we already covered the previous day, like yesterday's session, how to understand the delta table. Whenever you create a delta table, it will have a separate folder called underscore delta log. So that folder will have all the information about your transaction log, metadata, statistics. That's called JSON files, sequence JSON files, which is going to keep for every transaction. Going to keep for every transaction. Okay. So this is about delta features. Okay. So now we are done with the delta. Then tomorrow what we'll do, we'll start with advanced concepts. So meantime, we can go and revise previous sessions. Then it will help you for the next sessions. Okay. Any questions? Looks like some network issues. That's okay, fine. Maybe we'll see it tomorrow. Okay, thank you.
Yeah.
See you tomorrow.
This
Thank you, Ravi.
cloning is possible with different workspaces also, right, Ravi?
Yes, yes. Any workspace means like it's you have to give a complete path. You have to give a complete
okay.
path.
Okay. Yeah. Thank you.
So you have to give a complete path, then only you can access the table.
Okay.
Yeah.
Thank you, Ravi. Yeah.
Okay, thank you. See you tomorrow.